All right, the final part is going to be graphing. If you guys notice on the key, there are two t-charts, and your job is to know when to use both and when to just use one. The other thing, if you look at the printable answer key, and what's also going to be on the test is I will just have intercept, and on the review I have y-intercept. So when you look at the key, the printable key, I actually changed some of them to x-intercept. Um, because when you switch the points, instead of it being a y-intercept, it's an x-intercept. So let's go ahead and start with 25. Um, when I go for my information, I've got A is 1, B is 3. That makes my y-intercept 1, so I'm going to go ahead and put my point. As far as my left-right number, that's the -2, the opposite of h. Remember, h is contained in the exponent, and I'm looking to see what will make the exponent become 0. And -2 will make my exponent become 0. And then since nothing's added on to the end, my up-down number is 0, which is also my wall. And now I'm going to make my t-chart. When I make my t-chart, I'm just going to use 3 to the x. All right, so in for the x points are going to be 0, 1, and 2. And when I put those in, I actually already know my y-intercept. That is 1, because I got it from here. 1 gives me 3, and 2 gives me 9. And I forgot to write down the wall number, my asymptote. So putting in my points, I already got 0, 1, 1, 3, 2, 9. And now I'm going to shift all my points to the left 2. And then again, this is growth. Growth is a backwards L in exponential growth, so it's going to coast along the wall and then jump up dramatically. Going to 26. This is also exponential, but this is going to be decay. It's going to be a regular L. A is 2 and B is a fourth. And that makes my y-intercept 2. As far as my left-right number goes, I'll have -2, and my up-down number is -5. And so is the wall, which I'm going to go ahead and draw on the wall, and then my y-intercept. And because it's exponential, I will not need the second t-chart. Since it's decay, I'm going to use 0, which is the y-intercept. So I'm going to go ahead and put 2. But then decay, I'll use -1 and -2. And when I make my t-chart, I'll include the a, b, and x. So first, putting in -1, -1 is going to make my 1/4 turn into 4. And then this 1/4, which is now 4, 4 to the first power is 4. 4 times 2 is 8. So that's my point there. And then when I put the -2 into the 1/4, that makes 1/4 4 squared, which is 16. And 16 times -2 is 32. Or sorry, times 2. So I'm going to put those points in. And the only other point I'm actually going to put in is the -1, 8. And then these points are all going to shift left 2 and down 5. And then because I know the shape, it's a regular L, it's going to shoot down and then coast along the wall. All right, 3 more to go. 27. On 27, I'm going to be using both t-charts because I'll find the points for the exponential function and then inverse them for the log function. So when I find the inverse, I will leave out h and k, but right now my left-right number is 0 and my up-down number is wall. And here my wall is vertical and it is the left-right number. And when I find the inverse, it will be 2 to the x power, and that's exponential growth. And for a log function, that looks like a lowercase r. So a is 1, b is 2, and my x-intercept is 1, not the y-intercept. So putting points in for 0, or for x, 0, 1, 2, and I'm actually going to even put 3 in there. When I put these numbers in for 2 to the x power, I get 1, 2, 4, and 8. But those are not the points I'm going to graph. I'm going to graph the inverse. So I'm going to switch my x and y points around. And it's the points in blue, the ones that are circled, that I'm going to graph. So real quick, let me draw on my wall. My y-intercept is actually an x-intercept. There's 1, 0. There's 2, 1, 4, 2, and 8, 3. And then all of these points will shift up 1. And then since it's lowercase r, it's going to coast along the wall, turn, and then kind of flatten off a little bit again. All right, 27, I will also be using both t-charts because I will make the points for the exponential and then inverse them. So before I find the inverse, my left-right number is -1, my up-down number is 2. That means my wall, which is vertical, is -1. I'm going to go ahead and draw that in. Now when I'm ready to find the inverse, it'll just be of 1/3 to the x power, and that's what I'll use for my t-chart. So a is 1, b is a third, and decay always looks like decay, like a regular L. Now since it's decay, I'll use 0, -1, and -2. And when I put those in for x, those negative exponents flip 1/3 into a positive number. So 1, 3, and 9 are my y points. Now when I graph it, I'm going to flip them. These are the log points, and it's these, the ones that I'm circling, that I'm going to graph. Okay? So 1, 0, again, it's not a y-intercept now, it's an x-intercept. I'll have 3, -1, and 9, -2. And now all the points are going to move left 1 and up 2. And now I'll draw my decay shape. Okay? And the final graph. All right, for the final graph, it is also a log, but on this one, I'm going to rewrite it as log E. Going for my shape, my left-right number, excuse me, is the -2. My up-down number is 0. That's going to make my wall be -2. As far as my inverse, it will just be e to the x. And when I use my t-chart, I'm actually going to use 2.7 instead of the e button. That makes a1, b is 2.7, and my x-intercept is actually 1 instead. So putting my points for exponential growth, I'd use 0, 1, and 2. So these are the points or the y values I get once I put my exponents in. And now they're going to flip. And again, it's the circled points that I'm going to graph. So no longer is there a y-intercept, it's an x-intercept. I'm going to estimate 2.7, and I'm going to estimate 7.3. And then all of these points are going to shift down 2. And it's going to, I'm sorry, not down 2. Let me erase that. Left 2. And then it's going to coast up along the wall and go over. And that's your graphing. As far as the test is going to go, I think we're going to do the graphing part first, and then we'll do the solving part on Wednesday. Okay, that's it. Have a great weekend.